Previous video we actually do piezometer and classification of pressure. So now we actually gonna do this thing, YouTube mamometer. As mentioned earlier, I also say that the piezometer itself is it measures liquid only, okay, and has the formula of the simple absolute and gauge pressure formula, okay. So maybe I should update over here also. So for piezometer wise, it uses P gauge formula from number 4. Okay, it's pretty easy. So it's just PA minus the point A minus away the atmospheric pressure, you get the gauge pressure. So typically you would always would use this in calculation for this and this, I think. So this is the formula that is always being used. Yeah. So therefore let's go to YouTube mamometer. Okay, for its distribution wise, you can measure liquid and gas. Okay, as also say over here, this is the advantage over piezometer. And to overcome the difficulties, yeah, and then it consists of a tube, okay, formed in a shape like this. So this fluid is actually known, okay. So you have a fluid that is known, and then you put in whatever unknown fluid in here. Okay, this is somewhat your maybe some gas or some liquid. So maybe there will be an opening and then you just fill it in over here. So this is how it actually works. So so let's derive the relationship that can describe how this actually um how this works lah. Okay. So first thing first is to derive a relationship between P1 and P2. Okay, because so first thing first, typically you have to first target the point that you want to measure. So you give me a so I actually written down. So the deriving formula is to find a point in the fluid. Okay, whatever point you want. In our case is actually this point A. Okay, and we have to make relationship of this point with another point that is of the same height, because as you know rho g h, everything, the h can be constant, so the rho, only the rho g changes. Okay, so as I say earlier, since the height are the same, okay, if let's say this is the height are the same over here, okay, only the rho and the g are different for different fluids. This fluid is different from this pink color fluid, okay. So and nonetheless, this video only touch on YouTube mamometer, okay. So yeah, and P1 equals to PA, where this point 1 is equals to point A, and then point 2 is equals to P1 plus the rho 1, which is which is rho GH lah, okay. So it's just wherever point the pressure here. So you're just taking the pressure over here plus the pressure over here, okay, in order to get this point over here. So you want to make a relationship between P1 and P2. Okay, so maybe I should rewrite it as make relationship of this point with another point using height differences. Okay, so it can be same height, it can be difference of height, so it depends on how you want to do it. It's a little, I'm trying to derive a step-by-step thing so I can next time in the future I can follow. So yeah, and then once you get this, I hope you get what I mean. So the first thing we do is to get P1 equals to PA. Okay, so this is our point we want to measure, and then P2 is equals to P1 plus the fluid configurations is equals to PA plus rho 1 H1. Okay, so this P1 is actually PA so you just rewrite as PA plus rho 1 H1. So P2 itself is equated, okay, dependable on whatever P1 is. So P1 is the so-called the base variable now. So whatever P1 changes, P2 will change that thing, okay. So simply said that P1 P2 is in terms of P1 plus, okay, whatever height. So relationship of P2 and P3, okay, since P2 and P3 are the same height, okay, so P3 equals to P2, Okay, as we say, P.3 and point 2 are the same. And then for point 3, since P2 is same as P3, therefore point 3 is equals to this one, right? So it's this. It is also, okay, it is also the same as atmospheric pressure plus rho 2 H2, okay? This rho 2 H2 over here. So this is H2. So now we equate an equation. That is a next level up, okay? So at first is only P1 as the variable. Now after that P1 is being put inside the P2 equation. So whatever P1 changes, P2 change. So now P2 is also put inside P3 equation. So whatever P1 and P2 change, whatever P1 change, P2 will change, P2 will change P3. Okay, so it's ta-da. Anyway, so P3 is equals to PA plus rho 1 H1, which is this one, the same as this. Okay, make sure you know. So because they are the same point, okay, same height. Their rho may be different, okay, and their height may be different also. So therefore, P3 can be said that because now it's outside air already, now it's PATM over here. Okay, so PATM plus rho 2 H2, which is the height. Okay, and nonetheless, our objective ourselves is to eventually derive a formula that can take on this form. Okay, P gauge equals to absolute minus atmospheric. So all type of this this scenario, this configuration, we have to find the relationship, and then in order to set up an equation to get this equation, I would say. So yeah, so we just rewrite, okay, we just bring the relationship down only. We just bring this still over here. It's the same, okay. I didn't check your feeling, okay. I didn't bluff you, okay. It's the same. You can double check now. Okay. Now rearrange, okay. How do I rearrange? Good question. So yeah, I just bring rho one h1 over here. Yeah, that's minus. So PA. So now it's in terms of point A, okay. So now it's in terms of P1. So P1 itself, whatever P1 as I say, whatever P1 change, everything change ma. So P1 is the one that we set it to, the variable that we are working on. And then so now we with this relationship, okay, that that touches on the two fluids, okay. So two fluids meaning this pink fluid and the gray fluid, okay. So if you were to ask me how will you know that you already get this equation, okay, is that make sure whatever point, make sure when you set up the point itself, it touches on all the fluids, all the place that you want to measure. If there are density differences, you have to set up an equation, I would say. So now maybe I should give me a minute. Okay, so yeah. So we rewrite this already. When we rearrange, we just bring this over here. We have PA. So now PA itself is equals to P atmospheric plus this and this. And this portion here, okay, is give me a while. Okay, I have made some mistakes. So apparently is after this part, okay, this part itself is is to set relation between P1, P2 and P3. For this part is just simple rewriting only. Okay. And so I mean yeah. So therefore, in this case, just now we stop here, right? In this case, this one bring over to this side. Okay, so this is why we have our P gauge. The barrier equation that is over here. Okay, the number 4, which is also being described over, which is this lah. Okay, so eventually every time when you want to do this type of equation, I mean this type of like questions, okay, be it piezometer, YouTube meter, or whatever meter you want, okay, eventually you want to set up the equation in terms of all this, so that you can actually solve for a P gauge. because P gauge itself is very important. You need to know the pressure itself, the amount of pressure difference between the pressure, the absolute pressure and the atmospheric pressure. Okay, so you can do things with that. And then yeah, so if you were to ask me what is P gauge, okay, because I was wondering also what is P gauge. It's the difference between the height and the density itself. Okay, so if you know the H2, you know the H1, and you know your then because this one is known fluid. Okay, you can actually since you know all this already, you can actually find the amount of density, the amount of specific gravity of this fluid. Okay, otherwise you can also have this gauge. So the gauge itself has two gauges, so there will be maybe more lines. Maybe I should draw over here, maybe more lines. There will be like, maybe this is maybe this is 1 meter, and then this is, no, I mean 1 millimeter, 1 cm now, okay, this is maybe 5 cm kind of thing. So yeah, so if the fluid of this unknown fluid is the density itself is greater than this known fluid, okay, it will actually push down. So this gray portion will eventually like become over here, so it will be like that. So if it's lighter, then then you will not push in that manner. So maybe you'll be like that, and it won't be like that. So this is the key things that I realized. I may be wrong, but I don't think it's wrong. I mean, whatever. So just another recap is that PA, okay, P absolute is beaker plus water, okay, is the analogy, and then P atmospheric is just whatever beaker, the beaker that contains the water. So our purpose is to find the amount of water inside the beaker, the mass of the water. So similarly, we are trying to find the amount of pressure um, that is within our absolute pressure, which is which the absolute pressure contains the atmospheric pressure, which we don't want to actually calculate into it, because this is nothing we want to do, because our purpose is to calculate the mass of the water, not the mass of the you know so just a final summary is that first thing first, you need to find a point in the fluid. Okay, you can find whatever point in the fluid. You can find here, you can find here, you can find here, whatever you want. Okay, typically you will set a datum point in the middle. Okay, so this will be a datum point where, because it's pretty much easier to, because this this is the highest point already and then you'll go down, so you set the highest point as the datum point, and then you do it out, and therefore after which you make a relationship using this point. Okay, you make a relationship using this point, and then you sort it out. Okay, you sort it between different. Okay, so the complicated things come in when you have different fluids. Okay, different fluids and different height. So make relationship of this point of our point over here with other points, maybe P2, P3. This is the contact point between our known fluid and our unknown fluid, and this is the point. This is the point three. The point three is yeah, I think you get what I mean. So you have to really set up equation that really defines the changes. Okay, you have to make known of understanding between heights. Okay, same height, they have same pressure or something like that. So everything, yeah. And then after making relationship, then you can relate two or more fluids into an equation, which also what we have done. So which is like this equation over here. Okay, so once you get this equation, you can rearrange into um the equation of this form, and then you can easily find your P gauge. So um but however, if you're only one fluid, okay, like the piezometer, as you can see, piezometer itself is only one fluid, so you can straight away just use this formula as also mentioned earlier. So it's the same formula the change in height is just the gum we just bring over. The gauge is just goes to this. That's all. Okay. So one last thing is that if you were to remember, if you were to search Google for specific gravity or whatever things, right, it actually uses our YouTube meter. They actually use this method to find your specific gravity. And for the next video, I'll talk about measure the absolute gauge pressure difference between fluid containers. So between this and this. So between two fluids again. But this time round, I don't know whether is it sharper or maybe more accurate. So we'll see it in the next video.